Hey guys, and welcome to the coding section of multiple linear regression. So before start coding, we'll see our data set. So here is the data set as we have already seen in the tutorial video, the intuition video. This is R&D spend, administration spends, marketing spends, state. This is our independent variables, and these are dependent variable which you need to predict. So let's import these values one by one. So here it's our x is independent variable, so x is equal to data set dot ilog, all columns except, so we don't need this and we need all this, so except this we need all this. So except the fourth index value we need everything, the values. So let's run this. Okay, y equal to data set dot ilog. We only need our fourth value, that fourth index value, that is our profit. Or this sorry, here is which we want to predict. So now, as you can see, we cannot open this value because it's array are not supported, is have the categorical variables. We need to convert these categorical variables numeric. So from sklearn dot preprocessing import label encoder. What this label encoder do, it will create a separate numerical variables for the categorical variables 0, 1 and 2, because we have 3. So name it as label encoder, because we need to apply to the x. So label encoder categorical label encoder x. Now we will apply the label encoder to only the third index, which is at New York, California and Florida. Label encoder x dot fit transform x. We need, okay, so let's run this. Here if you can see our data set, here it has encoded the values 0, 1 and 2, but we need to create separate column for all these values. For this one hot encoder, we'll do the favor. So let's import this. So one hot encoder equal to encoder categorical features at index 3. Now let's encode all our x values, that is one hot encoder dot fit transform our x to array. So here are x values, it is encoded each one of them with a separate column, but we need to include only one. We need to exclude one. We don't need all three to prevent the dummy variable trap. So x equal to x except one, we need everything. So if you can see our data, it's look like this. We have excluded one. Now again, now importing our linear regression dot linear model import linear regression. So from sklearn dot model selection, we are going to import our splitting the data into train test. Not naming them x train, x test, y train, y test equal to train test, splitting xy values, taking test size to 0.3, random state is 0. Let's run this. Okay, now we will create a regressor from linear regression. Now we'll fit all the data we have, fitting the data to x train and y train. Okay, now data has been fit. Now we are going to check the error percentage. Since we cannot plot these graphs in high dimensions, we cannot see on our 2D, so we are going to check error percentage. This will show how accurate our model is. So before checking, we need to do some predictions. Let's do prediction on test values. Y predict test equal to regressor dot predict on y test. So if we run this, and here we have y test predicted values. Now let's check the error percentage. Error. In the previous video, I've already told you what is error percentage. This is the y true minus y predicted divided by y true into 100, and we'll take it as a mean because we are dealing with so much values, not one value. So np dot absolute. What is a y true? Y true or y test. Y predicted is y predicted test divided by y test. We'll take its mean. Np dot mean, multiplying it by 100 since we don't want the error percentage. So now taking its print. Now let's run this. Sorry, I made mistake. I wrote a y test here, so it's x test. That's why it is shown error. So now let's run. So it's 5.3, 5.8 approximately. It's a good predictions since we don't have a lot much data. It's 50 only 50 values. If we take a lot of data and experiment it with the test size, we can get better model. So you can experiment it more. Thank you.